All right, so I'm not going to probably do all these questions. We may not have time, but some of them I'll go back to with you later. But I'd like to start at question number 2 here. And question number 2 says, for each of the following, compare the two rates and determine the lower rate. Frozen ham is $2.58 a kilogram, or 22.6 cents per gram. So let's, oops, wrong one. To compare them, we're going to have to put them into similar units. So the units we're dealing with is $2.58 for each kilogram. And I'd like to compare it with 0.226 for every 100 grams. Okay. So what do you think we need to do in order to help these things get on the same page? What's a conversion I have to make here? Grams need to be turned into kilograms in order to compare these. So I'm going to make my conversion. Now let's think about this here. What do I want to take out of this problem? What do I want to remove? What units should disappear here? Kilograms should disappear. So that means, do I put kilograms on the top or the bottom? Yeah, so if I put kilograms on the top, and then I'll have grams on the bottom. And again, the reason is now kilograms will divide out of the top and bottom. So what's the conversion between kilograms and grams? Yeah, 1 kilogram has 1,000 grams. So now I'll be able to compare this. If you look at my units are going to be in dollars per gram, which is the same over here as dollars per gram. Okay, so can we compare these? One costs 22 cents, the other one costs 0.2 cents. Does that make sense? Why do you think they're so far out still? Pardon me? I just couldn't hear, that's all. Why do you think they're so far apart? Go ahead, France.
Because that's 0.226 is for 100 grams.
Yeah. Right, so the other one is in 100 grams. So we could go and then make a switch and get this into hundreds of grams. Yeah, another way to get it into per grams would be to divide this by 100, right? So I have 0.226. You could divide that by 100, and then I'd be in just grams. So if we divide it by 100, that's one way we could do it. Otherwise, you could try making a conversion on the other one as well. But let's go this way. That'll be 0.00226 per gram. So when you compare them, this is the cheaper rate here to start originally on this side. When you make your comparison, as long as your units are the same, you'll be okay to do your comparison. So you notice that the last comparison we're making is in dollars per gram on both of those. As long as they're the same units, you can make a comparison. You had a question?
Because like it would be acceptable to go into kilograms on a test, right?
You could change them all to kilograms. Yeah, you could have done made this one here. Why don't I just quickly do that alternate route that was suggested? $226, and I've got 100 grams. We could also have chosen to choose to turn this into kilograms. So I want grams gone, and I want kilograms here. 1,000 grams for every 1 kilogram. So you're going to get $2.26 per kilogram. And then you would have been able to compare the original two. These ones here. Sorry. 258 with 226. So yeah, as long as your units match, you're good. Okay, so let's try another one just to jog your memory. It is, yeah, that's pretty cheap for ham. Cycling speed is 35 kilometers an hour or 15 minutes to travel 4.5 miles. So I'll give you the conversions here, see how we can do. But we're looking at 35 kilometers per hour or, sorry, what was it, 4.5 miles in 15 minutes. So I'm going to let you guys work this one for a minute or two. Again, remember, you have to get your units into the same, you have to get your units to be the same. So if you didn't know, 1 mile is 1.6 kilometers. Whoops. So I'm going to choose to convert this one, and I'm going to make the units go to kilometers per hour. So what I start with is 4.5 miles in 15 minutes. And I'll make my conversion here. I'm not going to get there in one shot because I have a few things to do, but we can do them one at a time. So for example, I want miles out of this problem, and I want kilometers in. So this will get rid of miles and put kilometers in. 1.6 kilometers is 1 mile. Now if I take a look at where my problem is, I'm now in kilometers per minute. So what I need to do here is figure out how to get from minutes into hours. I want the minutes to disappear. So I got minutes would disappear top and bottom, and I want hours into the problem. So there are 60 minutes in 1 hour, and again you can double check. Minutes is gone, so the units that remain are kilometers per hour. Put them into your calculator, you should get 28.8 kilometers per hour. So this is the faster speed. 35 kilometers an hour is faster than 4.5 miles in 15 minutes. If you change, you should still get the same answer that this one was faster, but yes, you could have changed in different ways as long as your units matched up when you made the comparison. Okay, let's go back and we'll try another one here. This time it says we have fuel efficiency of 6.5 liters per 100 kilometers, or 38 liters travels 560 kilometers. So I'll write those two on the other sheet. We're looking at 6.5 liters for 100 kilometers. And we're going to compare it to 38 liters of fuel in 560. So, are our units in need of conversion here? No, they already line up. So at this point, since the units are the same, all we need to do is check to see what those numbers are. So for example, 6.5 out of 100, I could do this in my calculator. And I get, 6.5 divided by 100 is 0.065 liters per kilometer. And this one here, I could do the same. 38 divided by 560 is going to be 0.0679 liters per kilometer. So the only conversion that you had to make in this case was you're dealing with 100 kilometers and you're dealing with 500 kilometers. So all we did was shrink them down to a single kilometer.
Okay, so the second one?
The first one's actually more fuel efficient because the first one takes less liters of gasoline to drive a kilometer. Right? Okay, so there's one more in section 8.1. It's the speed of an object. So 10 meters per second or 60 kilometers per hour. So again, I'll leave you guys to work this out. 10 meters per second or 60 kilometers per hour. Which one is faster? Okay, so which one do you want to convert? Meters per second or kilometers per hour? Okay, if we start with 10 meters per second, at 10 meters per second, I need to get out of seconds and into hours. I don't think I would do that all in one shot. I'll use minutes as a stepping stone. So for example, there are 60 seconds in 1 minute. And that doesn't solve my problem, but I get a little closer because now I know that there is 60 minutes in 1 hour. And now I'm into meters per hour. So I don't want to be in meters per hour, I want to be in kilometers per hour. So I'll do that conversion then, out of meters. So meters needs to go on the bottom. That way meters would cancel out here. And it would be kilometers I want to get into. So 1 kilometer has 1,000 meters. So that's the series of conversions that you could do to get from meters per second into kilometers per hour. And let's figure out what that's going to be to compare them. So I end up with 36 kilometers per hour. How do you enter that into your calculator? So when you enter this into your calculator, everything along the top is a multiplication. So for me, it would have looked like this. 10 times 60 times 60 times 1, which you don't really need to do. And then I would say divided by everything on the bottom. So divided by 1, divided by 1. Again, you don't need to do multiplications and divisions by 1. And then divided by 1,000. So everything on the bottom you divide by, everything on top you multiply by. So yeah, 60 kilometers an hour is faster than 10 meters per second. Okay, so let's continue here. This is section 8.2 now. Based on her consistent pace and practice, Petra believes she can run her next marathon at a pace of 3.75 minutes per kilometer. An official marathon course is 42.195 kilometers long. To qualify, she must run the marathon in 3 hours and 40 minutes or better. If she manages to maintain her target pace, will she make it? So basically, she's practiced for this marathon, and she knows when she runs, this is the speed at which she can that she goes through. So this is how fast she runs, and this is how far she needs to be able to do it. And if she takes longer than 3:40, she won't make qualifying. I don't know if you guys have seen the Boston Marathon, but it's a pretty big deal. You have to be fairly good to just be invited to go. So let's take a look and figure out how we could work with this problem. I'm just going to transfer those numbers to the other page. It's 42.195 kilometers. Her speed is 3.75 minutes per kilometer. And the minimum time, she has to be faster than 3 hours and 45 minutes. Yeah, so part of what we're going to need to do here is figure out how can we calculate this? I mean, there's a few ways you can approach this problem to answer the question. So I'd like to hear your thoughts. How would you figure out if she's going to be fast enough to qualify? Aside from Ask Mr. Joyce.
Multiply the 3.75 according to the number, and then you get minutes, and then
Okay, so one suggestion that's just come up so far is to say why don't we multiply her pace by 42.195 kilometers. Then kilometers would cancel, and we'd be left with how many minutes it will take her to run the Boston Marathon. So yeah, that's one definite way we could answer this problem. So let's see how many minutes she takes. So 42.195 times 3.75 is 158.23 minutes. Okay, so can we make this comparison now? Not quite, right? We're in hours and minutes, whereas our answer is just minutes. Good, so 3 hours, you can make the change. Yeah, most of you will just multiply by 60, and that's great. I'm just going to be consistent here and using my units. So those would cancel, and I would have 180 minutes. So 3 hours is 180 minutes. The total of 3 hours and 45 minutes would be 180 plus 40, which is 220 minutes. So she seems awfully fast here. She does this in 160 minutes or less, but so yeah, she's definitely going to qualify. That is very fast for a marathon time. I'm having a hard time believing I don't have a mistake in here, but anyways. Okay, I'll let you just copy that down before we go to the next one. We do that there. Tim's brought up a good point. The other way you could solve this problem, I think this is what you're trying to explain to me, is you could also take a look at it as you have 220 minutes to run the marathon, and you know how fast she's going to run. It's right here. So you could go 220 minutes and multiply, let's see here, 1 kilometer is going to be done in 3.75 minutes. That'll tell us how many kilometers she runs in that 220 minutes. So 220 divided by 3.75 gives me 58.7 kilometers. And since that's farther than the marathon, which is only 42, right? Like it's easy. But anyways, she only needs to get to 42. She clearly will have finished before the marathon ended. So that's another way you can answer the same question. Okay, so let's move into, what do we have here? We have about a half an hour, so why don't we try one more in rates. Yeah, we'll do one more in rates before we move into the scale diagrams. So we'll take a look at Doris's carpet. She plans to order 10% extra so that she has enough to allow for cutting. She can buy her carpet for $36.95 per square. So at $36.95 per square yard, she can buy it from a store nearby at $33.99 per square yard. However, the same store charges $100 for delivery. So even though it's cheaper per square yard, she needs to know if it's worth it because there's a delivery fee. So we need to calculate a couple of costs here. All right. So here's the room. I'm going to let you guys strategize. Can you read the dimensions okay from back there? Okay, so I'll leave this for you to strategize, but you need to be able to answer which one of these is going to be a better deal for her. $36.95 per square yard or $33.99 per square yard. And I'll go write down the conversion for you from feet to yards. Okay, so 1 foot is 3 yards. Oh, got it backwards, sorry. 3 feet is 1 yard. 3 feet is 1 yard. Yeah, and don't forget about the 10% extra, because you don't want to put the carpet down in the room and have gaps. So anyways, I'll leave you to it for a few minutes, see if you can figure out which one's cheaper. So let's work it out together for the area of this room. I'll transfer it over to the other sheet. And roughly I have this diagram. And my artistic skills, that's not bad, I guess. So this is 6 foot. This is 12 foot. And this is 14 foot, 6 inches.
Or 6 inches, not 4.
Yeah, and this is 20 feet, 8 inches. So when you do this, I look at this picture and I can see 2 rectangles. So there's one rectangle, which is the black dotted line. And there's another one here. So if I want the area of the room, I have to add together those 2 pieces. So room number 1 is 6 feet by 12 feet. Now, one thing I'm going to do here, just to show you the way the units are going to go, I'm actually going to write feet so you can see what's going to happen. So I'll be at 72, and what do you think my units are? Feet squared, that's right. Feet, and they happen twice. So when we can do our conversion to yards, you'll see where this comes back in when we do yards. Because we have to see yards twice if we're going to do feet twice. So that's one of my rooms. For the other room, it's a little trickier because 14 foot 6 inches, there are 12 inches in 1 foot. So this is 0.5 feet. I could rewrite this then as 14.5 feet, and now I'll be able to use it in my calculation. You can't use it as 2 different measurements. It has to be together as the one. It could be all in inches, but it'd be easier if it's all in feet because we're going to use feet to get into yards. Okay, similarly for this piece here, 8 inches, if I convert that into 12 inches for 1 foot, that's going to be 0.75 feet. So I could write this as 20.75 feet. Now when I want to calculate the area, the second piece is 14.5 times 20.75. Oh, I'm sorry, did I? Yeah, you're right. Thank you, Madam Mayor. Yeah, it should be 6.7. So let's see here, 14.5 times 20.67. So this one is going to be 299.72 feet squared.
Big room.
So wait, minus 8.5 times 20.67, because you're not getting the top of the room.
Ah, good one. So did everybody see what Haley said?
Yeah.
Minus 4.6.
So how come it's not 14 and a half?
So it's only 6 feet of the room is the top part.
Right, 6 feet is the top. So in this room here, if I draw a green line, that's actually how wide the room is. It's not the entire 14 and a half feet. Okay, it's only this dashed line in green. So we do need to make a change. This green line here lost 6 feet, so it'll be 8.5 feet in width.
He's just testing us.
So this will be 8.5. And that leaves us with, well, let me multiply it out for you and then we'll figure out what's the area.
8.5, and it's 14.6.
Wouldn't it be 8.6, like 8 feet?
Sorry, 1 second, I'll grab your question. Let me just write this down. So, Haley, is that better now?
Yes.
Good stuff. The question was at the top? Is it okay? Okay, so now we know what the area of the room is. The area of the room is going to be 72 plus 175.7. So altogether we have 249.7. Sorry, 47.7. So how do we add 10% to this? Anybody work in retail? Yeah, times it by 1.1. So 10% extra. That means I'm going to go what I had before and multiply it by 1.1. So this means she needs 272.5 square feet. So now that we know how much carpet she needs, we have to be able to get it into yards in order to figure out how much it's going to cost from this dealer. So if I'm going to make my conversion, what did we say the conversion was for feet to yards? So 1 foot is 3 yards.
Other way around.
Right, that was the mistake I made the first time. Thank you. Okay, so if we're looking at this then, is that enough? Do I just multiply it and I'm done? Good. It's feet squared. So because it's feet squared, all I did was there's actually 2 feet here. And there's only 1. So I need to do it again. So that both of the feet are gone. And now my units are going to be in yards, square yards, which is what I wanted for the cost. And remember when we talked about, it's going to skip for a second, but I'll go back to it. When we talked about the scale factor, this would be the same thing as doing 1/3 with feet and yards, and then squaring it because I'm calculating area. So you could also do that instead of the multiplication twice. It's going to be the same thing. 272.5 divided by 9 is about 30.3 yards squared. So I'm going to let you guys finish off the problem. Which one should she order from if she needs 30.3 square yards? All right, so for company number 1, what's the cost from the first company? It is $36.95 for every square yard. So what's the cost then, or how do I figure it out? So this will get rid of yards from my problem, and I'll be left with just the dollar amount. So what did we get for this? Somebody with a calculator? So I have
1,000 something. 1,001.
so the first company is going to cost her about $1,100 and change. Let's see what the second company will charge her. The second company is $33.99. And then they add $100 for delivery, right? So I'll have to add $100 into this as well. So again, yards squared would disappear. And I'll end up here with 1,029, and that includes the 100?
Yeah. No.
Nope. Ah, so at the end it isn't the better deal. $33.99.
Could have been. How about the rental for the truck?
1 second. So 1129.90.
I picked the first one.
So yeah, it's $10 difference.
Or the second one.
Better in your pocket, so you might as well have the first company come deliver for you.
The rental.
The rental?
Oh, we never.
No, we assume this one's got their own truck. You don't have to rent one.
Also, they deliver too.
They deliver in that cost, yeah.
Oh. Okay.
Okay, so I want to shift now from our converting units into rates into our scale diagrams. So let's switch over. If you're taking your notes, you may want to kind of section it off here. So here's one that says, in Humboldt, Saskatchewan, there is a 2.4 meter by 2 meter reproduction of a stamp that honors John Diefenbaker. Canada's 13th Prime Minister. Let's see here. Impress Mr. Maloney. Can anybody tell me anything about Diefenbaker?
Yes, James and Tim or
He what?
Jerome.
Canceled the Avro Arrow. So you've seen the TV show then?
No, I did my historical.
Ah, okay. He was what?
Of German descent.
Why, are you just guessing by his last name? Well, do you guys know which party he belonged to?
Liberal.
No.
Wrong.
Conservative.
Yeah, Conservative Party. He, I believe, is he the longest running? He's up there. No, I know what it was. Harper just passed. I think Harper just passed him as. I think yesterday our Prime Minister just passed Diefenbaker in the list of longest Prime Ministers. So I think he was like 13th or something. Anyways, if this was the original stamp, what we want to do is figure out what scale was used to make the reproduction. So if it was 36 millimeters by 3 millimeters, and now it's 2.4 by 2, what's the scale factor they used to enlarge this? Okay, so let's, did anybody come up with an answer here? $15 millimeters for how many? Okay, well let's put it into a scale, like just one factor. So here's how we could work that out. We could take either side. So you could connect 2.4 with 36, or you could connect 2 with 3, or well, I guess 2 meters with 30 millimeters. So it doesn't matter, but let's start with 2 meters and 30 millimeters. Okay. Oops. Going to sleep. 1 second. Okay. So if we have 30 millimeters in the diagram, and that equals 2 meters in the real world, then one problem is they don't line up yet. So how do we get them to line up? Millimeters and meters are different units. So I need a rate here. What would you suggest?
1,000.
Yeah, there's 1,000 millimeters in 1 meter. And now you'll notice my units cancel.
And that leaves us with nothing.
And I have a fairly, oops. You know what, my apologies. Not really on my, 1 second, gang. So I need to make a small correction here. It's actually getting larger in the diagram. I've got my fraction upside down. So my apologies, but I guess I'm just used to things getting smaller when we do scale problems. Should have thought it through a little bit more. So there's 1,000 millimeters in every meter. So I'm going to end up with 1,500 as the scale factor. So that means if we were in the real object, whatever it was on the real object, we multiply by 1,500 to get up to the reproduction, which is 2.4 millimeters in size.
So what's the scale?
Yeah, let's figure that out. 2 divided by 30 times 1,000 is 66. We'll call it 66.7.
Oh my gosh.
Is that what you got?
I don't know how I got it, but
You don't know how, but it's there. Go buy a lotto ticket then. That's lucky.
I'm certain if I don't find 36. How about if I did?
Okay, let's keep moving forward here. So let's take a look at number 9 here, which has some shapes in it. Just give me a second. I think let's instead of doing number 9, number 10 is closer to stuff that we had talked about. So let's take a look at the 5 by 7 inch picture, and you're going to photocopy it to 110% to figure out what dimensions you'll get. And what percent will the area have increased? So if you start with 5 by 7, that means each dimension is going to be 110% larger. So how would you make something 110% larger? Times it by 1.1. So 5 inches, if I want to increase it 110%, it's now 5.5 inches. 7 inches times 1.1 is now 7.7 inches. So the picture is now 5.5 inches by 7.7 inches. And this will just jog your memory a little bit here. The area of the original is going to be 5 times 7, which is 35. The area of the copy is 5.5 times 7.7. Sorry, how much is it? 42.35. So if we were to compare how much larger they are, $42.35 compared to 35. I get 1.218 repeating. And if I was to look at the area, if it's 110% and I squared it, I'd get that 1.21 that I'm seeing over here. So remember, when you're using a scale factor, in area, you'll see it twice, so you have to square it. In volume, you'll see it 3 times, so you cube it. Okay, we'll try that again as well. Okay, so let's try some scale diagram questions. This is just a review to get you warmed up for the homework. So, all right. So this time, let's see. And I'm going to have you guys try these. We worked on these just the other day. They should still be fairly fresh in your memory. Serena sees a toy pig with a scale ratio of 1 to 16. She estimates the toy was about 10 centimeters long. And found a similar toy pig with a scale ratio of 1 to 64. Estimate the length of the online one. Okay, so think about how you could maybe answer this question, and I'll pause it here and we'll recap together. Okay, why don't we, it sounds like people might need a hand with this. Let's give it a try. So I'll show you one way that you could do this. It's probably the way I would expect most of you to start. 1 to 16, that means, say, 1 centimeter in the model. Well, I guess it's a toy. Let's call it the toy. Is 16 centimeters in the real world. So the pig or whatever we're looking for. So what we have is we've got 10 centimeters for the toy, and we need to convert this into the real world. So how can I do that? Right, so I'm going to multiply this by 16 in the real world for 1 in the toy. So now that I know the length of the real pig, I can use that 160 centimeters for the real pig. And now I want to use the other toy. So the other toy is 1 to 64, which means 1 centimeter in the toy is 64 centimeters on the real pig.
Totally different.
So how can I get into the toy then? Right now I have 160 centimeters on the real pig. How do I use that to get back into the other toy she sees? Yeah, that's right. So 1 centimeter for the toy is 64 centimeters in the real world, because that's going to knock out the real world and put us back into the toy size. So that's going to be 160 over 64. 2.5, which is 2.5 centimeters long.
Of the toy.
Yeah, for this is toy, right? Those are my units that I'm left with.
Okay.
And I believe that's what it asked, right? Estimate the length of the online toy, 2.5 centimeters.
She's so curious about it, so she searched it online.
Yep.
Wow.
Okay, we'll probably have time to do just a couple more here. So I'm going to skip into section 8.6 just to make sure we have a chance to talk about that. Hey, 15 looks a lot like one that we've already talked about. Toblerone bars. Anybody go buy a 10-pound Toblerone after? This time of year, the Toblerones are out, but I don't know if they have them locally, the 10-pound bars. Anyway, give this one a try. Remember, this unit 8.6 was asking you about those relationships with like area squared, volumes cubed. So see if you can do it without having to actually calculate all the necessary pieces there. See if you can use the scale factor squared or cubed. Okay, I believe that clock is a little slow, so we might get cut off here. I just remembered that it's a little bit slow. It says the manufacturer doubles the volume of the chocolate to create a similar bar, and then it says determine the surface area that is needed for the new bar. Okay, so there's a few ways you could answer this question, and if we get cut off, which we probably will, I'll finish it while you guys are in tutorial, so at least it shows up on YouTube. But I need to start here with just transferring my picture over. So it's 4, 4, 4. I think it's 20. Okay. So if we're going to double the volume, then what you need to think about, if you're going to answer this with a bit of a shortcut, you have to think about how the scale factors changed with volume. So what happens when you mess with volume? What happens in the scale factor? What are you doing with it? How many times do you see the scale factor in volume? 3 times, so you're cubing it, right? So if I was to figure this out, that means my scale factor, and your book uses K, is going to be cubed would have to be equal to 2 times the volume now.
K is scale factor.
Yeah, that's the scale factor. So this way, if I did this, I could figure out what happens to the scale factor. So instead of cubing it, I'm going to cube root it to undo that. And again, I'm trying to show you the shortcut here. I'll do the long way probably at the break while after the bell has gone. But in this way, I get the what the adjustment is quite quickly. Okay, so what I end up getting here is 1.26. So if I then wanted to figure out what would happen to the surface area, that means I would be able to take that number, 1.26, for the surface area. So I'll call it S for surface area. And remember, I'd have to square it to get the new surface area. So in the calculator, so if I look at the shape, oops, wrong one there. That means the old surface area here is going to be I have to add up each of these faces. So there's 3 of them. So it'll be 3 times 4 times 20. And that's the area for this region that I just shaded. Then I also have to add up these end pieces here, which I'll shade in black. Those ones, and then at the back here. So that's a triangle which has area 1/2, the base, which is 2, and the height, which I'll have to actually calculate. It's not given to me in the problem. So if that's a triangle, that means 2 squared plus 4 squared is the height squared. So I have 4 plus 16 is the height squared. So the height of this is the square root of 20, which gives me, let's see here, about 4.47. Okay, so I'll add all these up and we'll find out what we get for the old surface area. So I end up with 244.5 centimeters squared. So as I said, to get the new surface area, it's going to be 1.26. Surface area is 2 dimensions, so I'll see it twice, times 244.5. And that gives me 388.2 centimeters squared. So that's definitely a bit of a challenge to use the shortcut there, but that's one way that we could answer this question. The other way you could do it would be to figure it out by calculating the volume. So I'll just refer you to the textbook for a second here. There is a formula sheet for the volume of a prism, and let's just bring it back up. Okay, so it's in this section. There we go. So the volume is 1/2 the base times the height times the length, and we've already calculated that height as root 20. So let's go and find the volume. So the volume for the original is going to be 1/2 the base, which is 20. Sorry, the length, which is 20. The base, which was 4. Which has just made me realize that that's supposed to be a 4 because the base is 4. Which will change this answer back here. So I'll go fix that one up again in a second. Let's continue with the other way. Sorry, and there's 2 sides on this prism. But anyways, I would expect most people would have had trouble with that anyways, so it's probably not worth spending a lot of time on that method. In this one here, so I've got base times height, and we said it was root 20. So if I find the volume of the original, I get 178.9. So then if I doubled it, I'd get 357.8. Okay, and then our job was to figure out how the proportions would have changed. So we would have had to say 178.9 was the original. Because it's volume, I would take the scale factor cubed and make that 357.8. So that means the scale factor cubed is 357.8 over 178.9. And that's about 2. So k is going to be the cube root of 2, which was where we left off before, right here. Okay, so the shortcut was a little harder to figure out from the start, but it's a little easier to do less work to get the answer. So anyways, that scale, the surface area that we get from that is going to be, let's see, 240 plus 17.89. So that's 257.89. And that's from the original dimensions. And if we know that we're now using a scale factor of 1.26, and this is area, so I'll see it twice. Then we can figure out what the new one is. That's better. So we should get 409.4 centimeters cubed.